So today we're going to talk about the importance of sketches and just sketching out the circuit as a better way of understanding what's going on with the circuit. Um, Even the simplest circuit, it just helps to just get out a pencil and paper and sketch it out. So we're going to look at this and we'll apply it to the potentiometer, right? So we'll start with a simpler circuit, just a resistor between 5 volts and ground. And we know, and we can draw it this way, right? The resistor is the line there, and there's the ground symbol. And remember, this is kind of shorthand. Even though it doesn't look like a closed circuit, it is a closed circuit. It's the same thing as if we had a 5-volt power supply, or voltage source is the better way of referring to this, on the side here, and connecting the positive and negative like I'm showing here. So just a reminder that we're using the shorthand to do a complete circuit. So we know current will flow from 5 volts to ground through this resistor, and we know it will obey Ohm's law, right? So the voltage is equal to current times resistance, and we can solve for current as 5 over R, the voltage over R. So pretty simple. Hopefully we all remember that, got that down. Moving on, let's take a look at the circuit, but instead of a fixed resistor, we have a potentiometer, right? So we'll call it the 10K pot we were using in the lab. So remember, a potentiometer is a 3-terminal device, and we use the fixed terminals from 5 volt to ground, and the wiper is not connected to either of those, right? And in fact, what we did in the lab is we connected that wiper to the A0 terminal, which is what we read in through an analog digital converter that's in the Arduino. So it's reasonable to ask, looking at this circuit, what is the voltage at A0, right? So we're going to do the analysis very quickly to show how that works. So again, we know that current will flow from 5 volt to ground, and we know that the it'll obey the same Ohm's law, but in this case the resistance is divided between 2 parts of the potentiometer, right? So we're gonna have to kind of redraw this into an equivalent circuit. So we'll take this simple circuit I drew here and redraw it in as 2 different resistances, right, from 5 volts to ground, and that node in between then becomes the wire that we attach to A0. So I'm going to rename the resistances R1 and R2, R1 being above the wiper, R2 below, and the sum of those two obviously is the full resistance, which is 10K. So we can do this analysis now. It's just a little bit more complicated. Current still flows from 5 volts to ground, as we mentioned earlier, and it still obeys Ohm's law. So giving ourselves a little more room here, we can write over here on the left that the current is equal to that 5 volt voltage drop over the sum of the resistances. Remember, resistances in series simply add to each other, right? So this is the same expression I used above to look at the resistance across, the current through a fixed resistance. Now the second thing, A0, is the same. The voltage at A0 is the voltage drop across R2, which also obeys Ohm's law, right? That voltage is equal to I times R, or R times I. So we can write, and it's the same current, right? So we can write that the voltage at A0 is I times R2. Very straightforward. And now those two I's are the same, so we could substitute the top expression into the bottom expression and get a very simple expression for the voltage at A0. And it's equal to the ratio of R2, which is the resistance below the wiper, between the wiper and ground, and the sum of the 2 resistances, the total resistance of the potentiometer. And so you see this very simple ratio, and you can see that if you have the knob turned so the wiper is really close to ground, R2 is 0, and that voltage will be 0, which makes sense because it's right near ground. If you turn the knob all the way to the top, the resistance below the wiper is the sum of the 2 resistances, R1 plus R2. It's the total resistance, right? Or the other way to look at it is R1 is 0, and that means that ratio is unity, which means E0 is 5, which makes sense because the wiper is right near the 5 volt supply. So this circuit is actually a very powerful circuit. It's used an awful lot in electronics, and it's called a voltage divider. right? And its name is an obvious one, right? It's exactly what you'd expect it to be called. You can create any voltage you want between 5 volts and ground. There's a really important assumption here, and the assumption here is that whatever you got that hooked up to at A0 draws no current, that there's no current coming out of there. Obviously it might, depending on what you hooked up to, and that's what I want you to verify in the labs. In today's lab, we're going to, or in the lab this week, we're going to use that same circuit and use the current measurement of our multimeter and verify, or actually measure exactly what that current is. Currents are rarely zero, but this one's going to be pretty close. So we'll just stop it there, and we'll see you soon.